Hello everyone. I want to talk to you today about a concept that kind of builds on what you saw in the previous day's video. Okay, this is a problem from the last day that I created videos. So if you remember, there's your function. You took your partial with respect to x, you took your partial with respect to y. This was the really long problem, and you ended up with four points. 4 critical points, and then we went through and we classified 2 as saddle points, 1 is a max and 1 is a min. So please go back to those videos if you don't remember seeing this problem. All right, so then the question is what if I made the problem a little bit more interesting, and I said, we start off with this exact same function, but I say out of these 4 options, I only want the one such that x plus y equals 3.24. And that would only be this one, right? This is the only one such that x plus y is 3.24. So if we do that, if we come up with an original function and we also add to that a side piece where there's a constraint equation, then we're going to go about it in a different way, and this process is called Lagrange multipliers. All right, I'll write that down in a minute. So what do I mean about a constraint equation? It means if I tell you the x, you should be able to tell me the y, or vice versa. If x is 0, y is 3.24. If x is 1, y is 2.24. If x is 3, y is 0.24, right? So the determination of the x will allow you to quickly determine what the y is based off of this particular equation. So that's what a constraint equation is. It forces a relationship between the x and the y. All right, so the process that I'm going to go over now is called Lagrange multipliers. Okay, so I'm going to pull out a problem that is directly from your notes, and we'll just work our way through it. Okay, here we go. So please print this out and get a copy of it right in front of you so that you can follow along. Okay, mine reads, each week during the summer, the Parks and Recreation Department has 300 hours of instruction time available to offer tennis and swimming classes. Each tennis class requires 4 hours of instruction. So let's see, tennis, 4 hours. And each swimming classes requires 9 instruction hours. Okay, so swimming, 9 hours. Okay. If X tennis and Y swimming classes are offered each week, the expected weekly revenue will be this revenue function that they've given us. So the first thing they say is to write the constraint equation for this problem. Okay, so what do they tell us? They say between the tennis and the swimming hours, you have a total of 300 hours. So let's see, if there's 5 hours of tennis, it'll be 4 times 5. If there's 5 classes, there'll be 4 times 5 hours of tennis. If there's 10 classes, there'll be 4 times 10 hours of tennis. So if there's X classes of tennis, it'll be 4 times X. So 4 times the X plus, okay. Now notice they're saying that there are Y classes. So that would mean that if there are 9 hours for each one of those classes, this will be 9Y. So equals a total of 300 possible hours. So there's our constraint, okay. So the easy way to see whether this is a constraint equation is just let x equal 0. If x equals 0 there, you can quickly solve for the y. So yes, knowing the x allows you to solve for the y. Okay, so let's see. We have something that is being maximized and minimized, and we have another equation. So when you do this process, oftentimes you label one of them as f of xy and the other one g of xy. So your g of xy should be the one that organically equals 0. So what do I mean by that? If you look at the 2, then I'm going to subtract 300 from both sides of this one, minus 300, and what I get is 4x plus 9y minus 300 equals 0, right? You should be able to add or subtract and easily get to an equation that equals 0. Look at that, right? This is one that I'm going to label g of xy. Oops, like that. So g of xy will always be the function that always can organically equal 0 by an addition or a subtraction. This other one, I'm going to label this as f of xy. Okay, so in order to do the Lagrange multipliers, there is a process, and let me show you what that is. Okay, I'm going to put this on a separate sheet so that I don't run out of space. Okay, so let me write down what we have. We have f of xy equals negative 40 x squared plus 720 x plus 36 xy minus 27 y squared plus 324 y minus 7200. Okay, so that's what f is. Okay, and we also have g of xy, which equals 4x plus 9y minus 300, the one that organically equals 0. Like that. Okay, so Lagrange multipliers, the process is that the gradient of f equals lambda times the gradient of g. Now this looks complicated. It's basically an upside down triangle. Most students see it as that. Okay, please feel free to go look that up. What I'm saying is gradient, G-R-A-D-I-E-N-T. Okay, this is a fancy way of simply saying that f sub x equals lambda times g sub x. Notice what happens both with respect to x. And then over here, you could also say f sub y equals lambda times g sub y. Okay, both with respect to y. All right, so what a lot of students do is they make a box and they just write down what their partial derivatives are. So our f sub x then here equals, look here please, negative 80x plus 720 plus 36y, and that's it. And then f sub y equals, let's see, 0, 0, 36x plus 324. Oh, I missed one right here. Minus 54y plus 324. Okay, and actually it kind of bothers me that I kind of crammed that in there, so why don't I put that on a separate sheet? Here we go. So I'm just going to start over so that we don't have things crammed all in there. F sub x, let's go up here. Okay, I'll start again. So the derivative of this first one with respect to x is negative 80x plus 720 plus 36y, like that. And then f sub y, 0, 0, 36x minus 54y plus 324. Okay, that's much better. Okay, now we go to our g, which is here. Right, here's our g of xy. So let's write those down also. G sub x then equals 4, and g sub y then equals 9, like that. Okay, so I'm going to go back to this one and try to apply what I have using the information that I've gained with the partial derivatives. Okay, everything should be plug and chug. All of these pieces, f sub x, bam, g sub x, there you go, f sub y right there, and then g sub y right there. All right, so let me plug the things in that are appropriate. My f sub x now is negative 80 x plus 720 plus 36y equals lambda. My g sub x was 4. Okay, make sure you have that list in front of you. I only took it away because f sub y was 36 x rather, minus 54y plus 324 equals lambda times 9. Okay, I only took it away because I'm pretty sure you guys have a copy of the solution in your notes. All right, at this particular point, now that you have this set up, you want to solve both for lambda. Okay, so lambda basically is just a means to an end. It's going to allow you to get where you want to go. Okay, so for this one, let me zoom in so that you can see what I'm doing. In order to get the lambda by itself, I'm going to divide by 4 and divide by 4. And I get negative 20 x plus 360 plus 9y equals lambda. Okay, and over here, we want to divide both sides by 9. And what do we get? We get 4x minus 6y plus 36 is equal to lambda. Alright, so let me zoom out so that you can see them together. Okay, it's really important that you understand all you're doing at that point is you're solving both equations for lambda. Now the lambdas are equivalent to each other. This lambda is the same as that lambda. So if this equals lambda and that equal lambda, these two have to be equal to each other. Okay, so what am I saying? I'm arguing that negative 20x plus 360, wait, that number is wrong. I did that in my head. Hold on one second. 180. Please make the necessary correction. Okay. 180 plus 9y equals lambda, which also equals 4x minus 6y plus 36. So if they both equal lambda, these two equal each other. Okay, so that tells me that negative 20x plus 180 plus 9y equals 4x minus 6y plus 36. Okay. Let's see, let's get all of the x's on one side and all the y's on the other, because we're going to solve for one variable in terms of the other. Okay, so that's what I'm doing. So let's see, let's add 20x to both sides. And I'm going to add 6y to both sides. Okay, so that cancels. That cancels. I get 180 plus 15y here equals 24x plus 36.